Okay, 1.6. Identify that the greater the difference in acoustic impedance between two materials, the greater is the reflected proportion of the incident pulse. Now, I mentioned this in our previous video, but I did also state that the wave can also be refracted, so it can continue passing through other mediums within the scan. So just be aware of that in our 1.5 video. But for 1.6, we need to just give understanding around how acoustic impedance works and how it's reflected in its incident pulse. So different substances have a different acoustic impedance, which we've learned in our previous dot points with the tables. When an ultrasound pulse crosses our boundary between two different materials, some of that incident pulse is reflected back into the first material, giving an echo that can be recorded, while the remainder is refracted into the second material, and I just mentioned that at the start of the video. So the amount of the incident pulse that is reflected depends on the difference in acoustic impedance between the materials. And a large difference in acoustic impedance will mean that the more of the wave is reflected and the less transmitted by the boundary, which gives us a value close to 1, which gives us a clear boundary, and that's the values we want. We want a value of around about 1, so we can give clear boundaries to each organ or each material that we're testing. Anything that is obscure can give us a detailed recording of what we're trying to determine or diagnose. So the key things is here that different substances has different acoustic impedances, that the pulse can be reflected back dependent on the boundary and what is being reflected. However, don't forget that it can be also refracted and continue passing through the organ.